This video is for number one on the challenge problems. We're going to give you a little visual of this right here. We have some water, some phenolphthalein, a little bit of sodium hydroxide in here, which is just kind of a side thing. I have a copper penny, which is one of the reactants, and I have 16 molarity stock grade nitric acid. So I'm going to put this penny in with the nitric acid. We'll bring the computer up a little closer so you can see, but it's starting to get green. You can see that from there. I think you can see that. And then there's an amber hue coming out of it, and that amber hue is a gas, and it's nitrogen dioxide gas. Now, one of the other products is also water, which is, I think, pretty believable from this. And then a third product is copper nitrate, which we don't have any evidence of now, but we will at the very end of the experiment. So I'm just going to slide this back. We can kind of see this going kind of greenish on the bottom. It's spitting out this gas, and this gas is going through this tube, and it's going up through this tube here. And I don't know if I think you can see it bubbling down into this pink right here. Okay, and something's going to happen there, but I think we're going to take a little bit of a break watching that there, and then go to a screen share and do a little bit of problem solving, and then we'll come back and see what's happening with that. Oh, I kind of see the pink color maybe getting lighter here. We'll kind of see what happens to that over time as that NO2 gas goes through there. Okay, here we go. We go back to a screen share here, and I'm going to pull this up. And here is question number one. And this is so we got copper. I'm going to grab a spotter. We got copper plus nitric acid forms NO2 gas, copper nitrate, which we really haven't seen. And then we got H2O as a liquid, which is part of the system. All right, I already balanced the equation. Let's go to solving that. And it says we have 3.05 grams of copper penny. It reacts with excess nitric acid. What volume of NO2 gas is produced at STP? So just sliding to a mole train, maybe making this a little smaller and sliding that through. We can look, and we have grams of a copper penny, about 3 grams. It's a pure copper penny from 1960, actually. And then we're going to go to moles of copper. Then we're going to go to moles of NO2, and then we're going to go through 22.4 to liters. The grams to moles, moles to moles, moles to liters is going to be our pathway. And I kind of put this in here already. Make this bigger again as we go back. Just wanted to show that path. And let's take a look at what we have. So we got this equation right here. And it says, what volume of nitrogen dioxide gas can be produced at STP? And we need to put the molar mass of copper in here. So I'm going to just grab this, and I'm going to put a 63.6, and I'm going to put a 1 mole. So we end up dividing 3.05 divided by 63.6. We have much less than a mole. If you scooted back up to the equation above, you can see that the mole ratio is, if I can do that with this, let's try this. And you can see it's 2 NO2s for every 1 Cu. So I'll bring this back down here to what we have. And I'll grab a marker and say for every, so this is going to be 2 NO2s per 1 Cu. Where do I get that? From the balanced equation. So I've gone from grams of copper to moles of NO2, and 1 mole is 22.4 liters. So I'm just going to type in 22.4, and that's going to be per, whoops, the 1 mole looks like it's already written in there. So we take that, 3.05 divided by 63.6 times 2 times 22.4, and I think it ends up being 2.15 liters. about the size of a 2-liter bottle. So I'll just do that. Maybe I'll make it right here. 2.15 liters would be our answer there. Now, let's say we try to do the same experiment, but it was at 20 degrees Celsius in 0.980 atmospheres. We can't use the 22.4, but the other part of the problem we can still use. If I take 3.05 grams of copper, divide by the molar mass of copper, and we grab this spotlight here, and then times it by 2/1, I get my moles of NO2. So I'm going to kind of take this piece right here and take this, and if I took 3.05 divided by 63.6 times 2, I'd come up with an answer of, I think it's 0.0959. I'm going to take that, and that's just what I'm going to plug in down here, and that's going to be 0.0959, and that's moles, and it is NO2 because that's what we're trying to identify. So everything's got to be in terms of NO2. The NO2 is at 20 degrees Celsius, which is 293 Kelvin. It's at 0.980 atmospheres, and we're going to use the 0.0821 liter atmospheres per mole K because the atmospheres match up, the Ks match up, the moles match up, so we're going to get an answer in liters. And then I just got to do the math here. And if I do the math, I'm going to do this right here. I'm going to take this box here and say this equals, and that's going to be, throw in my numbers, NRT. I'm going to throw a N, which is, parentheses, 0.0, we'll do 0.0959. And then we're going to times that by R, which is 2.0821 times, let's see, temperature was 293, and then we're going to divide that by, I'll be a little line right here, that pressure of 0.980. So let's go in, put 0.980 there, 0.980. And what do we end up with? I think it equals 2.35 liters. This kind of represents, and that would still be NO2, and it really represents room conditions, maybe pressure slightly less than normal, making it bigger, and the temperature is a little bit bigger than 0 degrees, which makes it slightly bigger, maybe about 10% bigger right there. Okay, if we were doing the next question, what we would do is percent yield equals the actual yield, 0.150, over 2.35, times it by 100, and we're going to get a percentage right there. So again, there's an example of a mole train to do one at STP, one using PB equals NRT, and then you get a percent yield. We got to go back to the last act here to our experiment. So I'm going to stop the share, and I'm going to turn this around, and we have something going on here with our experiment. Let me see if I can line this up so you can see it. That's pretty good. So notice this is all red over here, and this is cleared up. So this NO2 gas is actually acidic, and there was a base in here, which is pink in the presence of phenolphthalein, and the acid, kind of like acid rain, turned it to a clear, which would be acidic or neutral. Now you can't see this, but water is climbing up here, and what happened is after the reaction was done, the temperature of this got hot initially, but then it started to cool down after it was done. And as it cooled down, the molecules moved more slowly. And as they moved more slowly, we'll get the little bit of the top in there, what they struck the sides of the container with less force and less often, and it created a lower pressure system here. So the pressure of air in the room is going through and pushing down on this water, pushing it up. I don't think you can see this right here, but the water level's right up here. Now, what's going to happen when it hits the top? We will see. Okay, so I think we're about 30 seconds and counting. 29, 28, 27, 26, and probably less time than that. It's right up here right now. And we'll watch this whole thing because we're still looking for our copper nitrate. Where is that in our system? Where did the copper penny go? Okay, now it's starting to flow through here, and pretty soon the whole thing's going to go through. Watch over here. What happens? Okay, there is our copper solution. The penny is gone. The penny has been converted to copper plus 2 solution, which is that blue solution, and that is the copper nitrate. That is the end of the demonstration. You got some problems to work on, but a pretty cool demonstration as well. All right, thanks for watching, and